Okay, I thought I'd go ahead and go through the study guide since I'm kind of on a roll making videos for you guys that need them. And we had problems like this where we have three sides of a triangle and they all are going to be proportional. And let me get my drawing tool up. Okay, so one side times a number plus the other side times some number plus 9 times another. The three sides added together would all equal the perimeter. But of course, our triangle is bigger by a common factor. So you could even call it a scale factor. It's up by a certain amount. So I'm going to just simply add this together. 7, 8, and 12. And 9 is 21. X equals 357. And then I need to divide 357 divided by 21. And X would equal 17. So the measure of each side then would be 17 will give you the one side, which would be 85. And then the next side, 7 times 17 will give you 119. And then 9 times 17 will give you 153. Add those up together. 153 plus 119 plus 85 equals 357. So each side would be 85, 119, and 153 for the triangle. That would have a perimeter of 357 in that proportion, 5, 7, and 9. Okay. And this one, we just did this one yesterday. So we have a angle bisector here. So that means we're proportional this way and this way. So I can say x over 9 is proportional to 16 over 6. I could reduce, or I could just cross multiply. And I get 144. Divide by 6, and I get x equal 24. Okay. Okay, so here we have one of the flagpole sort of a pictures. Everything is labeled for us. Find the height of the flagpole to the nearest 1/10 of a foot. Okay, so that's our variable. We can set up, these are similar triangles, so I can set up 5 to 10 equals x to 36. Now, you could see right away that I have a 1 to 2 ratio here, so I could just kind of think in my head, 18 times 2 is 36. But let's go ahead and work it out if you didn't see that. So 10x equals 36 times 5 is 180. Divide by 10, x equals 18. So our flagpole is 18 feet high. That seems reasonable. All right, we did this kind of problem yesterday. We have AD is 36, DB is 42, EB is 21, CE is X. All right, so parallel lines mean that we have proportional parts. So I can set up X to 21 equals 36 to 42, and other varieties of ways I could do it as well. X over 36, 21 over 42. And all of those ways. So let's cross multiply. 21 times 36 equals 756. So 42x equals 756 divided by 42 equals 18. So CE would be 18. All right, are they similar? If so, write a similarity statement and scale factor if not, explain your reasoning. Are they similar? Well, they have to be proportional in all their parts. And so again, I'm not going to get too hung up on what matches what. I'm just going to go from small to big. So 9, 12, 14.4, and 15. These should all equal 15 to 20 to 24 and 25. Reduce these. 9 divided by 15 is 0.6. 12 divided by 20 is 0.6. 14.4 divided by 24 is 0.6. So far we're looking good. 15 divided by 25 is 0.6. So every ratio is equal, therefore they are proportional. So this is yes, and the similarity statement would be matching. Start with your angles. So we're going to match. If we go Q, R, S, P, we're going to start with J, go to K, go to L and M. Okay. And then our scale factor is 0.6. Again, to turn 0.6 into a decimal, I'm going to either reduce or I'm going to use my calculator to take that decimal. I'm going to hit the second button and then the arrow button to turn it into a fraction. So a scale factor of 3/5. Okay, it's a problem like we had on Tuesday. I keep saying yesterday, but it was Tuesday, which is actually right now. I need to figure out how big this is. So all of it's 28 minus 8 leaves 20 for this. Then I can say that 3x minus 5 over 20 equals 10 over 8. We should see a proportion there. Again, I could reduce this proportion, and I'm going to do it without, for those of you that don't want to reduce your proportion. Okay. 8 times 3 is 24x. 8 times 5 is 40. 24x equals 240. Divide by 24, x equals 10. Okay, the scale of the map is 0.5 to 15. On the map, the distance between two cities is 2.5 inches. What is the actual distance between the two cities? So inches to miles, inches to miles, inches to miles. So the miles is what's in question. So 0.5 inches, we're doing inches compared to miles, inches to miles compared to inches to actual distance would be in miles. Okay. So 0.5x equals 15 times 2.5, and that is 37.5, divided by 0.5 is 75. 75 miles is your actual distance. is BC parallel to DE? If they are, if it is, then these parts would be proportional. So we need to see if they are. AD is 15, DB is 12, AE is 10, EC is 8. All right. Is 10 to 15 equal to 8 to 12? Again, I went this way. You could have gone this way or bid the arrows in the other direction, and it's all good. If the easiest probably the way to do this is just to cross multiply, and they should be equal. 120 would equal 8 times 15, and that is also 120. So because the cross multiplying is equal, I can say yes, they're proportional. So yes, because of proportional parts. It's hard to say. Okay. Are these triangles similar? Write a similarity statement. Okay. Well, we don't have parallel lines written here. So we're going with small triangle and a big triangle. So we need to prove that we have a shared angle. So our only possibility here is going to be side angle side. Right? Because we don't have a third side. We don't have this. And that's all we can go with. So right now I know this is not it. They may not be similar, so we'll have to check that out. All right, so that means that 3 to 6 must equal, I'm going to add up the big triangle, which is 4, big triangle, to 8. 3 to 6 is 1/2, 4 to 8 is 1/2, so 1/2 equals 1/2. So these are proportional. And now I got to check the right similarity statement. So we have O, here's my quick trick. O needs to match O, because O is the same angle in both triangles. O is not in the same place here, so this is not going to work. O is in first and O is third. So that's out. They are similar. This is our answer. Okay, now it says they are similar. Solve for x. So we have proportional parts. X is the big piece here. All right, so small triangle, big triangle. Oops, 52. Okay, I'm going to reduce this to 1/2. It's going to make this a lot easier. 1/2 equals x over 52. Well, x is going to need to be half of 52, so go ahead and cross multiply just to show you why that works. X equals half of 52, so that's going to be 26. Okay. Oops. Out of that page, I need to go over here to, ooh, this is long. We may need to do, let's see, where did I end up? I've done, oh, I guess I've done the left side of all of it. Okay, that's what's weird, because I'm just kind of going down. Now I need to do the right side of all of it. I thought I was only 1/4 of the way done. All right, so here's our shadow problem. So we have a lighthouse and a 140-foot shadow. lamppost 5.8 feet tall, and a 7-foot shadow. So height of the lighthouse is what we need. So lots of ways to do this. That's one way. You could say height over height equals shadow over shadow. And then actually use that to calculate 7x equals 140 times 5.8. And that is 812. Divide by 7, divide by 7. 812 divided by 7 is 116. All right, so we've got a proof. We haven't done a lot of work with proofs, but really this is, you're going to find, is just kind of what we have talked about. So it says that MQ is parallel to OP. Prove that they are similar triangles. All right, well, what do we have? We have shared angle, or not a shared, a vertical angle here. And whenever you have parallel lines, this can act like a transversal, giving you alternate interior angles. So the reason here is that this is given. That's always the first statement in a proof. Now they're saying angle QMN, that's the one I noted here, is congruent to OPN, and the reason is because of alternate interior angles. Are congruent, so the properties of alternate interior angles. So we use that. And we're going to cite another set of alternate interior angles. Well, the other one that we didn't name is this one. Let me put 3 there. These. So angle MQN, NQM, congruent to NOP. Okay, that works right here. So that's the statement you want here. And then the last thing is the similarity statement. And why are they similar? Well, what we have is 3 congruent angles. So it is by angle similarity. Okay. Yeah, I marked that one, but the vertical angles actually wasn't mentioned, so that's all good. All right, are they similar? All right, only possibility would be side angle side, because that's all you're given here to work with. We just need to prove similarity. So kind of matching up the 70 degrees, and 10 over 15, 10 to 15, this side to this side, equals 14 to 21. 14 to 21. I can kind of look at these numbers and tell, well, I can reduce 5 out of here, so that would be 2/3. I could reduce 7 out of here, so that would be 2/3. And 2/3 equals 2/3. So yes, they are they're similar by side angle side. Okay, so scale factor, again, it's just the ratio. So we're going to say, we're going to match up the sides, small to small, big to big. Reduce these numbers. 12 over 10 is, I can factor out a 2, and I get 6/5. So the scale factor would be 6/5. All right, now we got to graph. So graph the triangle. There's L. -1, 2, M. O is 2, 0, -2, O. And graph the dilation. So I'm going to take each point and dilate it from the origin. So that's helpful. That's easier to do. Because now I'm just going to go, how far away is it from the origin? I'm going to do it 4 times that, times 4. So 2, 2 times 4 would be 8, 8. That's L prime. 0, -2 is going to be 0, -8. That's going to be right here, O prime. M, -1, 2 is going to be -4, 8. I'm just multiplying the coordinates by 4. And now I have this big triangle. It's 4 times bigger than the one it started with. Okay, now we're going to get smaller. -10, 10. Point right here. We'll call that R. So -10, 10 times 2/5. Okay, we're going to divide by 5. That makes it 2. And so this is going to equal -4, 4. -4, 4. And that's R prime. So we're getting, we're reducing this shape. Keep going, 0, 5. 0, 5 times 2/5. 0 times 0 is going to stay 0. 5 times 2/5 becomes 2. So this is S. S prime is going to be 0, 2. And then T is going to be at -5, -5. And -5, -5 times 2/5 is -2, -2. This is T, this is T prime. So we got smaller by 2/5. And are we done? Are we done? Yes, we are. All right. So I hope that helps, and we will talk to you later.